Welcome to this topic, energy changes. So far, we've looked at the introduction to rates of reactions. We also looked at factors that affect rates of reactions. In this video, we're going to take a look at chemical equilibrium and a short topic called energy changes. So we're going to start with chemical equilibrium. Chemical equilibrium, or the point of equilibrium, is the point where the rate of forward reaction is equal to the rate of reverse reaction. So there are some reactions which are said to be reversible reactions. By the way, the symbol for reversible reactions are these two half arrows. So the definition for reversible reaction is a reaction that proceeds in the forward and backwards direction. So in these reactions, products are going to be formed from the reactants, and again, the same products are going to break down into the reactants. An example of the illustration of a reversible reaction is this. Well, this reactant reacting with this reactant, forming C and D, then C and D also combine in a certain way to form back A and B. So this reaction is a reversible reaction. So we look at characteristics of equilibrium reactions. Just as an emphasis, the point of equilibrium, or reactions that have reached equilibrium, we have the speed at which products have been formed to be equal to the speed at which reactants have been formed. So the first is the same point that I'm mentioning. The rate of forward reaction is the same as the rate of backward reaction. Second, the concentration of reactants and products remain constant at equilibrium. What does this mean? Since the speed at which products have been formed is the same as the speed at which reactants have been formed, so if reactants have been used to change into products, again we expect the same number of products to be combined to form reactants. So those reactants which were used up are going to be replaced, making the concentration of reactants the same. So if you measure the concentration, you might think that the reaction is not happening, but the reaction is proceeding, but at equal rates forward and backwards. One point also to note is an equilibrium can only be established in a closed system. A closed system is a system that has no any kind of interaction with the external environment. It cannot be affected by external pressure, external temperature, and the likes. As an emphasis, mean that in equilibrium there is no loss or gain of external materials by the reacting system. They don't gain or lose anything to the external environment. Next, look at a concept of enthalpy. Enthalpy is the amount of energy in 1 mole of a substance. Given 1 mole of anything, the amount of energy in that anything is what is called enthalpy. The symbol is H, and it happens that during reactions, reactants have a change in enthalpy when they become products, which simply means when you have got these reactants with a certain energy, when they become products, they are going to have a different energy. So we use what is called an energy level diagram to represent these changes in enthalpy. So we're going to start 2 types of reactions that have to do with heat. The first one is endothermic reaction. Endo means inside, thermic has to do with temperature or heat. So endothermic reaction is simply a reaction which absorbs heat energy from the surroundings. So if there is for this reaction to occur, it has to absorb heat from the surroundings. Endo, inside, thermic, heat. So taking heat inside, that's what endothermic reactions. So here are some examples of endothermic reactions. The first is photosynthesis. We all know what photosynthesis is. In this photosynthesis, the reaction can only occur if there is sunlight. So this process absorbs heat from the sun for it to occur. The chemical equation for photosynthesis is this, where carbon dioxide reacts with water to form glucose and oxygen. Another example is photography. So photography is a process that has to do with silver salts. So in this photography, The essential reaction is that is the reduction of silver ions to metallic silver. So in silver source, there is a silver ion and another ion. So this silver ion is going to be reduced to metallic silver. The word reduction means the gaining of an electron. So with exposure to light energy, the silver salts break up into ions as follows. For example, we're going to use silver bromide. So silver bromide breaks into the constituent ions that makes it up with exposure to light. Okay, so this is this is where the endothermic part comes in. So when light is absorbed, it's going to separate silver and bromine. Once they are separated, this silver is going to gain an electron and form the silver metal. This process is called reduction, where something gains an electron. Its opposite is oxidation, where something loses an electron. So this way, reduction silver ion simply means the silver ion gaining an electron. So this is an example of an endothermic reaction. So here are some characteristics of endothermic reactions. The first is energy is absorbed from the surroundings. Okay, for this reaction to occur, it has to steal energy from the surroundings. The second is reactants have less energy than products. So if reactants have 20 joules, when that energy is absorbed, the products are going to have that energy as part of them. So they are going to have a higher energy. The change in enthalpy is positive. I'm going to illustrate this using a diagram. But before I do that, let's take a look at one more characteristic. The temperature of the entire system falls. Where does it go? It is absorbed by the system, by the reaction. So this is an energy level diagram. So to illustrate endothermic reaction, we have reactants at a certain energy. They are going to gain some energy and products are going to be formed. So the change in enthalpy is positive. What does it mean? It means when you subtract the energy of reactants from products, you are going to get a positive number because products are bigger, have a bigger value of energy as compared to reactants. Next, we look at exothermic reactions. Exo means outside, thermic heat. So exothermic reactions are just reactions in which energy is given out to the surroundings. Examples of exothermic reactions. The first is combustion. So combustion is any kind of reaction where oxygen reacts with something or where something is burned. So it's an example of exothermic reaction. During combustion, heat is released. That's why we see H-mbili. Second is tissue respiration. Tissue respiration is the process that produces energy in our body. When you eat food, that food has to be broken down, and the breaking down releases energy, the energy that we use to do our muscular activities and the likes. So this is the reaction of tissue respiration. It is in a way opposite of photosynthesis. Glucose reacts with oxygen to form carbon dioxide and water and energy. So in this one, we have seen that energy is released to the surroundings. The reactants also, sorry, let me just say that again. So these are the two examples. So now the characteristics of exothermic reactions are: 1, energy is given out to the surroundings. 2, reactants have more energy than products. Why? Because the energy of the reactants is part of it is given out to the surroundings, so mean that the products are going to have less energy, meaning that the change in enthalpy is negative. Change in enthalpy is usually calculated as the energy of the products minus energy of the reactants. So if the energy of the products is less than the energy of the reactants, we're going to have a negative value. Also, the temperature of the system increases. So another interesting one is bonds formed are relatively stronger than bonds broken. Exothermic reaction is usually said to be a bond forming process, then endothermic as bond breaking process. So that I didn't want to go into details, but what you should get is the bonds that are formed are stronger than bonds broken. When these reactions are happening, for reactants to be formed, there are some bonds that are formed. So when bonds have been formed, energy is given out to the surrounding. Okay, so if there are any bonds that have been broken, they are going to be the energy needed to break those bonds is not going to be is going to be less than the energy needed to form bonds. So here is the energy level diagram for exothermic reaction. So reactants have a high energy, then products have a lower energy. The change in energy is negative, because to calculate change in enthalpy, we say product minus reactant. So any small number minus a bigger number is going to be negative.